show what are the contributing factor for it to decide. Let's say, I think this one is a diabetic patient. I think it's based on BMI, BMI, pregnancies, serum insulin, triceps, and age. These are the top 5 contributing factors for this particular patient. So yeah, so just to recall, within AutoML, it will choose the best performing model based on your primary metric. Then within the best performing model, it will also create an explanatory model for you to see the performance and the contributing factors for that decision making. Any questions so far? Okay, none.
No. So far,
Nope.
no questions.
Yep, no worries. Okay, so the next thing that we'll do is we're gonna deploy the model. So for us to do that is here. So you choose the model that you wanted to deploy, so that we'll be able to create an Azure container instance. So this is the endpoint of the prediction or the inference capability. Okay, so we'll choose stack ensemble, and we'll just need to press deploy. So when we press deploy, we just need to give it a name, AutoML diabetes endpoint. Let's say this, I've already pre-created it. That's why it's saying that it already exists. Then the compute type, whether you want to deploy it in a Kubernetes cluster or a container instance. So in the example that I'll be showing, I just deployed it in a container instance since it's a very small prediction Docker container. Then you choose whether to enable authentication and other advanced features from SSL, the number of CPU, the memory or the RAM, and so on. So we'll just keep it at default. Afterwards, just need to press deploy. And then when you go to your endpoints, it will be shown here. So you have AutoML diabetes endpoint. So it will provide a REST endpoint for you that you can use in testing out with your own data. And on top of that, you can also do some testing on this end, or if you are writing your own application via C#, Python, or R, it also has some predefined script, which I'll be showing that as well later on, and some deployment logs. All right. Then if we're gonna go back to the experiments, within the experiments, so this is where I'm tracking the diabetes AutoML. So these are all the runs that I did before, and it was able to track each of the individual runs, how long it takes, what's the compute target, and what's the best performing features that I have, or feature model that I have. We just go to the actual endpoint. You can just copy this and we'll show that later on. And the next thing that I'll be showing is, so what if you don't want to use this this graphical user interface? You wanted to use a notebook instead. So what you can do is you can go to the notebooks and you can use the Azure Machine Learning SDK to build your own AutoML. So same principle, but in a programmatic way. So you just need to connect to your AutoML Workspace. An example. Then afterwards, you'll just need to upload your data, or if the data is already existing, then it will say that the data is already registered. Not sure why it's taking a while. Just restart the kernel. Then afterwards, you just need to create your compute cluster. But if the cluster already exists, it will just ignore this particular line of code. Okay, I think it's done. Then data is already registered. Then you just need to put your cluster name. So it should say that the cluster already exists. Then you start configuring your AutoML features programmatically. So you can drop a column. I dropped ID. You can drop or determine which algorithms you want to exclude during the experimentation. Then some AutoML configurations. The name of the experiments or the name of the AutoML, classification type, timeout, basically the same feature that we clicked a while ago, but this is more in a Pythonic way. So once it's done, provide all of these configurations, normalize macro, amount of concurrent iterations, etc. Then the next thing you'll do is just run or submit the model. So I think we have a question. If I created it in AutoML, will it have an automatic notebook equivalent? If not, can I convert it to a notebook? So I believe it doesn't automatically convert it into a notebook, but all the artifacts that you need to build a notebook will be in the AutoML feature. So if we go back to EXP experiment AutoML, all the outputs of each of the individual models will be here. So all the artifacts, the pickle files, etc., so that you can replicate it via notebook if you want. But there's no direct conversion to a notebook. Even on the individual model, you also have all the programmatic artifacts as well of what was executed by AutoML. So I'll just quickly go back to the notebook. So it's starting to submit and perform the experiments. So it will take a while to do that. All right. So this is the method via notebook using AutoML. Then the next thing that I wanted to show is the actual usage or the prediction type, which is the blue line, this one. So within the diabetes endpoint, I think we need to copy the REST endpoint or use one of these codes. So I actually prepared a Python notebook for this. So using this actual script. So we'll do first the notebook way. So we'll just go to automated ML scoring. Automated ML scoring. I just actually copied the code. Then just run the code. Put in your data from here. Then it will show you the result. So given this data set from this pregnancy, plasma glucose, and all other details, it actually predicts that it's potentially the patient is diabetic. So this is if you want to embed it within your own Python application. But if there are also other alternatives, so you can consume it via C# or even via R, depending on where you want to build your application. Or if you want, if you're familiar with the Postman, this is where you submit, get, post a RESTful request to an API. You can also use that to trial this API. So you just copy the REST endpoint, paste it here, then put in the header. Content type is, trying to zoom in. Yeah, content type, application/JSON. Then you put in the body. You can have each of these metrics of this list is a patient data. Then we just need to press send. It will provide. So patient 10 million is possibly diabetic, whereas patient 2 is possibly not diabetic. So this is just one of the ways to consume your API. But then just for the sake of completion, we have the Azure Container Instance, and I actually built a React app. This is how the React app looks like. So it's a form where you just need to put all your details, and then it will check if you're diabetic or not. I need to create an API management. The reason why I need an API management, it's because I think it's because of the cross-origin resource sharing. So since the web application that I built, the AutoML Diabetes, and the API, which is Azure Container Instance, do not share the same origin or the same domain, I need a cross-origin request. Hence, I need API management to take care of the CORS or cross-origin resource sharing. So I built an API management in here. Then within the API management, I just registered the diabetes endpoint and enable CORS. So I enabled CORS for my local host 3000. Then within the diabetes ML, I just need to create a score post operation. The same as what I have in my Postman. It's a score as well. And it's a post request. Then from there, I can have that API. So it will create a separate link or a separate API for me or gateway. So Azure Demo API Management, Azure.api that I can embed in my React script. So this is just a sample React script. You have your URL here, and then the post request or the URL, which is score, and just need some subscription key just for authentication purposes. Then afterwards, I was able to build the AutoML, have that and add some values or input some values from these different fields, and then I can check whether I'm diabetic or not. And I can change some of these values. Let's say the BMI is 30, then the result changed. So this is one way to consume the application. So just to recap, I built and deployed the model in Azure Container Instance. I built API management to allow cross-origin resource sharing. Then the React app will access the container instance via API management. And the user just needs to input the data so that I'll have this particular small applications. So yeah, so this is how the AutoML works. So let's see where we are at right now with the actual AutoML. So it's still running. So it's still performing some of the test. I think it will keep going over the next 15 minutes. It's just been running for 18 minutes. But afterwards, you can do the same thing of deploying it, or even if you submit it by Jupyter Notebook, you will also have the same features under the Azure ML platform. So yeah, I think that's it for me. So in this particular session, we managed to use Azure AutoML feature to build and experiment different algorithms, hyperparameter tuning, feature engineering. Afterwards, we deploy it in Azure Container Instance and consume it using a React app via API management service. Any questions? No worries. They can connect to me on LinkedIn and then send a message. More than happy to answer their questions. I'll just post my LinkedIn profile here. What do you mean? Write the results back to reconfigure the data model.
So let me unmute Pio if that is okay. So thank you very much, Emil, first of all, for the great conversation. So the point is that, let us say we are doing a customer service survey, so we have a whole bunch of like commentary from, bunch of different students, as an example, in the educational institution. And what we're actually trying to find out is, let us say, typical, right, cognitive services, key phrases, sentiment, things like that. Now, as we hook literally, we compose a data model from the survey. We take, that one column that actually has comments, we hook it up to cognitive services. As we bring back the data, we clearly want it to reside within that data model that we've actually constructed, because it's got all it's got the proper fact table, it's got all the master tables and things like that, and we want the results to sit within the confines of that. Yeah, you follow me, right? So what is the most elegant way of doing that?
I think, if you correct me if I'm wrong, I think if you wanted to use the data model that you have, I think you need to create some sort of a master data, a presentation layer on top of your existing data model that you can use to ingest directly to the prediction pipeline, or used for the training pipeline, because you just need a single denormalized table when building a machine learning model. Did I answer your question?
Got it. In the interest of time, got it. I'll follow up with you perhaps later. But thank you very much for sharing your LinkedIn profile. Much appreciated.
Yeah, so you can follow me or connect me in my LinkedIn profile. It's Emil Lawrence Pastor. Awesome.
Awesome.
Awesome. No worries. Yeah, so thank you very much, Pia, for the invitation. I think, it's good to start exploring AutoML. I think as more and more organizations will start considering this to solve their most common problems, from churn modeling or any marketing, campaign analytics, marketing analytics type of problem, risk, so that you can focus your effort on building the more sophisticated model in more challenging